This section of Introduction to Wolfram Notebooks is about notebook features that are helpful for creating, documenting, and sharing computer programs. To illustrate some of those features, here is a notebook from a project in image processing. This notebook contains programs and comments and programming notes all organized into sections, and in the last section are inputs that create interactive applications and deploy those applications in the Wolfram Cloud. This input, for example, gives an interactive application with sliders for adjusting parameters in an image processing program, and the next input deploys this application in the cloud. Evaluating that input gives a hyperlink, and clicking the hyperlink brings up a web browser that shows another Wolfram notebook, this time displayed in the web browser, and within this notebook is the same interactive application. Returning now to the notebook on the desktop, one of the most useful features of notebooks for programming comes from the overall structure of a notebook itself. Notebooks are organized into cells, which are identified by cell brackets on the right side of the window. The different types of cells provide natural places for entering different types of content, like programs and background information, and anything else that might be relevant to the project. For larger projects, it is convenient to organize the project by organizing the cells into groups, like the section groups in this notebook. Section groups can be closed by double-clicking the grouping bracket to give an outline overview of the project, and to work on some part of the program, closed sections can be reopened by double-clicking the same bracket or by clicking this icon in the heading of a closed cell. At a more detailed level, notebooks support a number of features to help with entering programs. Starting with an empty notebook, input is treated by default as Wolfram Language code in an input cell. As these inputs are being entered, various buttons and menus appear automatically to help with entering the program, along with highlighting and changing colors and various other things to help with spelling and syntax. One of the buttons is this icon below the left end of the cell insertion bar. The cell insertion bar is this horizontal line that indicates where a new cell will appear. Clicking that icon brings up a menu of choices for how the next input should be handled. The first choice is Wolfram Language input, which is the default, and the second choice is Freeform input, which provides for entering programs in ordinary language. For example, choosing Freeform input and entering Remove Small Components from an image brings up a template for the Delete Small Components function. Natural language input can also be indicated by entering an equal sign as the first character in the input. This input runs an image processing operation called delete border components. For general programming, freeform inputs like these have the disadvantage of often being ambiguous, since different phrasing or terminology can give different interpretations, but there are also many situations where freeform input is quite useful. There are many programming tools that pop up during input. For example, returning to the import command as a file name is being entered, a button labeled File Browser appears that you can click to bring up the operating system file browser, which can be used to select a file. That file browser can also be accessed by choosing the File Path item under the Insert menu. Perhaps the most conspicuous programming tool that pops up is the Suggestions bar, which appears after each output and gives a row of buttons for operations that are commonly done with that output. The last output here is an image, so the Suggestions bar in this example gives buttons for operations that are typically done on images. Some operations are simple and can be done right away, like rotating the image. For example, clicking the Rotate 90 degree right button enters and evaluates the input for rotating the image. For more complicated operations, like edge detection, the buttons in the Suggestions bar do more complicated things. For example, clicking the Detect Features button brings up a menu of choices, one of which is edge detection, which is an operation with 2 parameters and an option. Choosing that menu item brings up this dialog box for setting up the operation. After making some selections, clicking Done gives the Wolfram Language code to produce the chosen result, with the function arguments and the options already filled in. The Suggestions bar does take up a certain amount of space on the computer screen, of course, so for times when you are not using it, you can turn the Suggestions bar off by clicking this little circle on the right side of the window. After that, you will see a different circle, which you can click to turn the Suggestions bar back on. For now, the Suggestions bar will be left off. Another way of generating code, or at least templates for code, is through the menus that pop up as commands are being entered. For example, here is a short manipulate program, and as this program is being entered, there are several menus and buttons that pop up automatically. This particular program gives a result with a slider for adjusting a parameter in an image processing operation. To take a closer look at the menus that popped up as that program was being entered, consider entering that input again. The first menu that pops up is a menu of choices for completing the name of the command. Choosing one of the items in that menu completes the name, and after that there is another button that can be clicked to bring up a menu of templates for filling in the arguments of that function. This example shows choosing the second template and then filling in the template. Similar menus and buttons appear for each new command, and as each placeholder in the template is filled in, you can use the Tab key to move to the next placeholder. The appearance option is not part of the template, so that can just be typed in. At any point, to get a reminder of what the function arguments are supposed to look like, you can hover the mouse pointer over the name of the function and click the button with the arrows on it, which brings up this summary. The other button, the circle with the eye in it, brings up the documentation for the function. Template menus can also be shown by choosing Make Template from the Edit menu. For example, to access the template menu for the erosion function, you can select the erosion command, position the insertion point immediately to the right of that command, and choose Make Template, or use the keyboard shortcut to bring up the template menu. Here, select the second template and use that to complete the input. At any point while working on the program, the notebook can be saved in the cloud. Save to Cloud under the File menu saves the notebook in the current cloud account, and Publish to Cloud saves the notebook with a link for sharing the notebook with other people. For example, choosing Save to Cloud saves the notebook in the cloud, and after that you could move to a web browser on this computer or on another computer and open the notebook in the cloud. This shows the notebook opened in a Wolfram 1 account where the saved notebook can be opened to continue working on the program in the web browser. Editing, command completion, template menus, and other features continue to work here much as they did on the desktop. Instead of a standalone application like the one in that example, there are many programming projects where the result is a function definition or some other code that is intended to be used in other programs or as part of a larger project. For example, here is a version of that example where the concluding section gives the definition of a function. This particular function can be applied to an image to count droplets in the image. One way of saving that function so that it can be used in another session or in another program is to first mark the cell with the definition as an initialization cell, which can be done by selecting the cell and choosing Initialization Cell from the Cell Properties submenu of the Cell menu. This also adds a gray background to the cell since the style sheet for this notebook adds a gray background to initialization cells. Initialization cells are cells that are marked to be evaluated when a notebook is opened, but a second use of initialization cells is in saving the notebook in a form called a package that can be used to load and evaluate the initialization cells into another session. For example, choosing Save As from the File menu brings up a dialog box where you can choose to save the notebook as a Wolfram Language package. After that, you can load the saved file into another session using the Get function, which loads and evaluates initialization cells to add the definition of the droplet counts function to that session. A convenient way to organize the process of creating a package is to start by choosing Wolfram Language Package from the New Package Script submenu under the File menu, which gives a notebook with styles and options set up specifically to help with creating packages. Unlike other notebooks, typing into this notebook gives an initialization cell by default, and saving this notebook saves the notebook by default as a Wolfram Language package rather than as a notebook. This notebook editor also has other features for package development, like these buttons for navigating to particular function definitions or to different sections of the notebook. That's the end of the examples for this section. You can find more information on features for entering code by opening the Wolfram documentation and searching for Predictive Interface, where there are descriptions of the suggestions bar and the command completion menus and other topics that came up in this section. The documentation also includes a selection of workflows that give step-by-step instructions for accomplishing many common tasks, like this guide on various ways of using freeform input. All of these features have been designed to be sufficiently intuitive that in many cases if a button or a menu or something pops up, just going ahead and clicking on it is a good way to figure out what it does and how to use it.